Hello viewers, welcome back to my channel. This is the last video lesson on scalars and vectors. And in the course of this video lesson, we are going to look at an important aspect of vectors, which is the resolution of vectors. We'll begin by looking at an introduction to vector resolution. So what is vector resolution? Vector resolution is the determination of the effect of a single vector on its component. So we are looking at what will be the effect of a particular vector on its component. And what are the components? We are talking about the x and y axis, or better put, we are talking about the horizontal and the vertical component. So we are talking about what will be the effect of a particular vector on this component, that is the horizontal and vertical component. So what do we mean? When we have a single vector, this vector can have an effect or can exert its effect only on one particular axis, maybe on the x-axis or on the y-axis, or even on both axes. So what do we mean by that? So let's say we have two planes, plane A and plane B. So this plane here represents the component we are talking about, either the x or the y component. So these are the components. So the blocks we have resting on this plane are the vectors. So we are going to look at each block. Now we will start with block A. Now block A is only resting on plane A, meaning block A has effect on plane A, but it has no effect on plane B. So in this case, block A has an effect on plane A, but not plane B. So when we look at block C has an effect on plane B, but it has no effect on plane A. But when we look at block B is resting on plane A, and it is also resting on plane B. So it has effect both on plane A and plane B. So this means that some vectors can have effect only on the x-axis, then others could have effect only on the y-axis, while some could have effect both on the x and the y-axis. So going back to our previous video lesson, we looked at this cardinal point. We said we have four major cardinal points, which are the north, the west, the east, and the south. So a particular vector could rest on just this axis, meaning that the vector has an effect on the x-axis. So remember, this is the x-axis, or better put, the positive x-axis. Then this is the positive y, then this is the negative y, then this is the negative x. So a vector could have an effect on this x-axis, either to the positive x or to the negative x. Another vector could have an effect on the positive y, either to this positive y or to the negative y, all on the y-axis. Then some could have effect in between. So in this case, if we have a vector here, this direction is towards the northeast. So it has effect both on the north and also on the east. Similarly, a vector like this that is between south and east has effect both on the east and both on the south. This is why we said some vectors could have effect in one direction, others vectors could have effect in multiple directions. So how do we calculate for what we call the component vectors? So if we have a vector v, now this vector has effect both on the y, so we refer to it as vy. Also, this vector have effect on the x-axis and refer to it as vx. Now vx and vy are what we call component vectors. So in your exam, you could be told to calculate the value of a particular component vector, either the horizontal, which is vx, or the vertical, which is vy. So you could be told to calculate for either of them. So how do you calculate for them? So we are going to close up this part. When we close it up, we have a triangle. So now if this is vy, it means that this opposite side will also be vy. So we have something like this. So we have this as v, we have this at the bottom as vx, and we have this right here as vy. and then we have our angle within as theta. So how then do we calculate? So when we have this, we can call this side opposite. We can call this side the adjacent. Then the longest side over there, here is the hypotenuse. So we are just going to label the sides properly. So we now have the opposite. Opposite is opposite because it's facing this angle. Then hypotenuse because it's the longest side. Then adjacent, that's the other side left. So when we treat opposite and hypotenuse, we have sine. So remember our trigonometry where we have so, ka, twa. So for the sine is opposite over hypotenuse. So in this case, sine theta is equal to opposite over hypotenuse. So our sine theta remains sine theta. Then opposite here is Vy. So this Vy over hypotenuse is the V here. So when we cross multiply, Vy is equal to V sine theta. So when you are told to calculate the vertical component, you are just simply going to make use of this formula. Vy is equal to V sine theta. So when we are told to calculate the horizontal component, so the horizontal here is adjacent. And then we are going to compare it with this hypotenuse, which you already know. So AH here brings us to cosine. So in this case, cos theta, which is cosine of the angle, is equal to adjacent over the longest side, which is the hypotenuse. So in this case, cos theta is equal to the adjacent, which is Vx over the hypotenuse, which is V. So when we do a cross multiplication, Vx is equal to V cos theta. So this is how we calculate for the horizontal component of the velocity. So we are going to look at this case. In this case, what is the difference is that this angle here is to the vertical. And if you could recall from our previous video lesson, we said that angles to be used are always angle to the horizontal. This is very key in solving any question that has to do with vectors. So angles to be used are always angle to the horizontal. And like we said, never use an angle to the vertical. So this is the right angle you are supposed to use. So in a case when you are given something like this, before you can find Vy and Vx, always find this part. And how will you find this part? Simply say 90 minus the angle given to the vertical. So if, for example, we are given here to be 60 degrees, I can't use this 60 to solve because it is an angle to the vertical. So this is not accepted in calculation. So what you are simply going to do is that we are going to find this angle to the horizontal. So I'm simply going to say 90 minus 60, which will give us 30 degrees. So at the end of the day, I'm going to use 30 degrees in calculation. So when you get that, you are still going to stick with this formula. Vy is equal to V sine theta for calculating the vertical component of the vector. And then Vx is equal to V cos theta for calculating the horizontal component of the vector. In this section, we are going to solve some practice questions. And the first question is, a box is pulled with a rope inclined at 30 degrees to the horizontal with a force of 150 Newton. The first part of the question is, what is the vertical component of the applied force? The second part is, what is the horizontal component of that same applied force? Now, if we are to place this in a diagrammatic form, we are going to have this. So we have a box, and this box is pulled with a rope, but the rope is not pulled horizontally or vertically, but it is pulled at an angle of 30 degrees to the horizontal. So this is horizontal. So the box is pulled with a rope at an angle of 30 degrees to the horizontal. And the applied force is 150 Newton. We are told to find the vertical component, which is this, let's say Fy. And then we are told to find the horizontal component, let's say Fx. So we are looking for both components. So how do we find the vertical component? So to the A part of the question, to find the vertical component Fy, remember our formula, it will be F sine theta. So in this case, Fy will be the force, which is 150 sine of the angle. Now the angle here is 30 degrees, and we can rightly use this because this is an angle to the horizontal. So that's sine 30 degrees. So Fy will simply be 150 times sine 30 is 1/2. And this will leave us with an answer of 75 Newton. So this is the vertical component of the applied force. So to the B part, we have Fx, and Fx will be will be calculated using F cos theta. So Fx will be the force, which is 150 cos 30 degrees. So Fx will be 150 times √3/2. So when we do our calculation, Fx will leave us at 75, because 150 divided by 2 is 75, √3 Newton. So this is the answer to both questions. So question 2, we have a diagram, which is a JAMB 1998 question. And the question reads, a body on the ground is acted upon by a force of 10 Newton at a point P as shown in the diagram above. What force is needed to stop? Now there's a key statement here, or a keyword rather, which is stop the body from moving towards the east. That's why they said eastward. So we are going to find what is the force pulling it towards the east, so that we can now know what force is needed to stop the body. So now we are going to find the force acting in this direction. So we are looking for Fx in this case. So we know that Fx will be calculated using F cos theta. So in this case, Fx will be F, which is the force, 10 cos 60 degrees. So in this case, Fx will be 10 times cos 60 is 1/2. So half of 10 will leave us with 5 Newton. So it simply means that this body or this object is pulled towards the east with a force of 5 Newton. So we have something like this, 5 Newton pulling it towards the east. So meaning to stop it, we have to apply a force in the opposite. So to stop a body, you are going to apply a force in the opposite direction. So you are going to counter it in the opposite direction. So since the force towards this is 5 Newton, so to counter it or to stop it, we are going to apply a force of 5 Newton, but in this case towards the west. So our answer to this question is 5 Newton in the direction of west. So this leaves us with option P. So the third question is a practice question for you, and the question is, a force of 10 Newton is applied to a block of wood as illustrated below. Now we have that diagram, and the question is, what is the vertical component of the force? Option A is 3 Newton, B is 5√3 Newton, C is 5 Newton, and option D is 10 Newton. So solve the question and then leave your answer in the comment section of this video. So viewers, this brings us to the end of the video lessons on scalars and vectors. So I hope you gained something from this class. If you have any question, comments or suggestion, do it to leave them in the comment section beneath this video lesson. And also do it to like this video lesson and share this video lesson to your friends so that we can all learn together. If you are new here or you have been watching this video lesson and you haven't subscribed to this channel, do it to click on the subscription icon and also turn on the notification bell so that you always get notified whenever I release a new video. So till you get to see my next video, do have a wonderful time.